so much fucking design on right now.
Alright, good morning, good afternoon, good evening, ladies and gentlemen, wherever you're watching me from. My name is Mr. Manuel, hosting this program, Mars Academy, Ghana. Make sure you do also subscribe to my channel so that if I drop any video, you're going to have access to it, right? Alright, we were on indices in our previous lessons, and we are not done yet, but we have to suspend some of the subtopics, especially under solving equations involving indices. We'll have to study linear equations for those who have never learned, based on the JHS and the SHS syllabus before. Are we okay? So we have to tackle algebraic expressions, and then we'll run into linear equations, then we tackle that one. It's going to be easier that way than we just trying to explain concepts from something we've not learned before. Are we okay? So we are going to suspend everything we are doing under indices, and then we tackle algebraic expressions, right? So as you know, we have to copy our notes, right? So make sure you pause the video and then you copy from here down to that part, right? If you've copied the notes, congratulations. Now I've been receiving complaints that some of you don't see my handwriting, so I decided to increase my size of font, right? And you can even zoom, please, if you can't see. Okay, so let's head to the explanations. If you've copied the notes, congratulations. Algebraic expressions refers to a collection of letters and numbers combined with at least one operation sign. So in algebraic expressions, you'll be seeing something like letters and numbers working hand in hand. All right. For example, 2p, you see a letter and a number, 2p. Very soon you will know the relationship between the number and the letter as you go forward. Okay, you see there is an operation sign, right? 3q, there is another operation sign and a number. So you are going to be seeing something like this when you talk about algebraic expressions. Are we okay? Now some notes behind here, or key concepts for us to consider. Every expression is made of terms. Terms. Now when you talk of the terms are the ones separated by the operation signs. That is either plus or minus. It can be times, or that is multiplication sign, or it can be the division sign. Okay, so for example, a typical example here, we have 2p and 3q being separated by what? Plus, or the addition sign. Then it means 2p is a term on its own, 3q is a term on its own, as well as 2, because it's also separated by the minus sign. Are we okay? So any particular part of an expression that is separated by either plus, minus, times, or division, then we call that particular thing a term. Are we okay? So 2p is a term on its own, 3q is a term on its own, as well as 2 is a term on its own. Are we okay? Now let's go to the next one. A number on its own in an expression is called a constant. So if you have a raw number in an expression, then that is called a constant. You can't call this a constant because the number has a variable attached to it, as well as 3q. But 2 stands alone. So 2 becomes our constant in this expression. But mind you, for expressions, you don't have to do away with the sign. Are we okay? So the constant term here is -2. Are we okay? The constant term here is -2. A raw number in an expression is called the constant. Are we okay? In every term, numbers are written first before the letters. A typical example is this. I never wrote p2. Right, that is inappropriate when you are studying algebraic expressions, but rather what you are expected to write is the number first before the letter. Are you okay? Good. Now there are technical things you are supposed to know when you are dealing with algebraic expressions too. Now you can see I have 3xy, right, and I've labeled some parts. Now the number with the variables is called the coefficient. is called the coefficient of the variables. So if I tell you to, or if you are being asked to tell us the coefficient of xy, that will be 3. Are we okay? So the number attached to the variable becomes the coefficient of the variables. And remember, I was using letters because we are now new to the topic. Are we okay? But the technical term is variables. Are we okay? Instead of saying letters, we say variables. As for numbers, it's still numbers. All right. The last one, only like terms can be added or subtracted. Only like terms can be subtracted or added. Can be added or subtracted. Yeah. Now, let's say you have mangoes and then you have apples. Are you okay? I give you 5 mangoes and I give you 5 apples. You cannot add them. All you tell me is, okay, so I have 5 mangoes and 5 what? Apples. What if I give you 3 mangoes and 4 mangoes? You are going to tell me at the end of the day having what? 7 mangoes, right? That is because mango and mango, they are like terms. But mango and apples are never what? Like terms. A typical example, let's say you have 2, let's see x to be our ice creams. Are we okay? 2 ice creams plus 4 ice creams. At the end of the day, we are going to get 6 ice creams. We had 6 ice creams because ice creams are like terms. What if we had ice cream with a pregnant baby? Are we okay? What am I even saying? An ice cream which is pregnant. You can't add 4 ice creams which are pregnant to 4 ice creams which are not pregnant. Hope you are getting what I'm trying to demonstrate. So always remember, they must be like before you add or subtract. Are we okay? That is very good. If you've not copied, make sure you copy in 5, 4, 3, 2, 1. Alright, we are going to look at our first subtopic under algebraic expressions, that is addition and subtraction of, or you can say addition and subtraction in algebraic expressions. So you are going to learn how to add and subtract what algebraic expressions. We are going to use the method of what grouping like terms. We are going to use the method of what grouping like terms. Don't let the vocab or scare you. It is just something simple. Are you okay? So you are going to pick a set of examples as usual. I'm going to solve the first one with you, and then you are going to do the second one on your own. Are you okay? Alright, these are the questions I'm going to solve with you under example number 1. Are you okay? So you are going to start solving. So let's pick our solution. Example number 1, A. Are we okay? We have 5x plus 4 minus 9y plus 3x plus 2y minus 7. This is where our grouping of like terms comes in. Are we okay? Now what you are going to do is you pick the very first term. Remember terms, right? You pick the first term, which is 5x. You look for somebody that is also having x. Are we okay? You can't add mangoes to apples. Remember that. So 5x. Who is a family of 5x? That will be 3x. Are we okay? Now you check the sign in front of that 3x. That is a positive sign. So you carry that number, that term together with a sign, and then you bring it in front of the first term you identify. So 5x is the term we are noticing first. Who is a family member to 5x? Positive 3x. So you write it, positive 3x. Now you go to the next number. The next number is positive 4. So you write it, positive 4. 4 is just a constant, a raw number. So you also look for a raw number as a family member. Are you okay? So positive 4. Who is also without a variable? Negative 7. And then you come with negative 7. The next one is going to be, we are done with 5x, we are done with 4. The next one is going to be negative 9y. So you write it, negative 9y. Who will be a family to negative 9y? That will be positive 2y. Are we okay? Positive 2y. We are done grouping like terms. Once you finish grouping like terms, this is what you are going to do. 5x plus 3x. 5 mangoes plus 3 mangoes. You are going to get 8 mangoes. Are we okay? 5x plus 3x gives us 8x. Very simple. Now, 4 minus 7. This is very simple. Are we okay? Let's see positives as money we have. Are we okay? And let's see negatives as our debt. Are we okay? Let's say we owe somebody. Are we okay? So I have 4 cedis. Are we okay? And then I owe 7 cedis. I'm going to pay with my 4 cedis so that I will owe the person 3 cedis. Does it make sense? So positive means I have 4 cedis and then I owe 7 cedis. So if I pay with the 4 cedis that I'm having, then I'm going to owe 3 cedis now. Very simple. Now I owe 9 cedis. Are we okay? 9y. I owe 9 cedis and then I'm having only 2 cedis. I'm going to pay with the 2 cedis so that I will owe 7 cedis. Remember, this one has the variables attached to them. You can't simplify further. So this becomes our answer. Very simple. Let us pick the second one. So this becomes A, this becomes B, right? We have 4x plus 2y plus 3x plus 5y. 4x. Who is a friend to 4x? Positive 3x is a friend to 4x. Then we come to positive 2y, the next number. Who is a friend to positive 2y? Positive 5y. Are we okay? Now 4x plus 3x, 4 mangoes plus 3 mangoes. You are going to get is it 7 mangoes plus 2 mangoes plus 5 mangoes gives us 7 mangoes. Very simple. And the last one, we have 2p minus 3q plus 3p plus 5q. Are we okay? As usual, we pick the first one. We have 2p, who is a friend to 2p. 2p has positive 3p as his friend, right? So positive 3p. From 2p, we go to negative 3q. So negative 3q. Who is a friend to negative 3q? Positive 5q. Are we okay? So positive 5q. And then 2p plus 3q gives us 5p. As usual, I owe 3 cedis, right? Or let's say I owe 3 queens, right? And I went to pay, or I'm having 5 queens. I'll pay with the 5 queens and then I'll be giving a change, right? I owe 3 cedis. I paid 5 cedis. So I'm going to be giving a change of what? 2 cedis. Remember, that change is not a debt, so it's not negative, rather positive. Positive 2, Q. And that becomes our answer. If you follow this far, kudos. Now next set is going to be solved by you. Anticipate. Example number 2 is going to be solved by you. So make sure you pause the video. I'm going to solve right now, so pause the video and work it out before you check the solutions. All right, if you cheat, God is watching. All right, so those who paused and then you solve, we are going to the solutions. All right, so make sure you compare your answers. So for the first one, A, we have 7a plus 3b minus 2a minus 4b. Good. As usual, we take the first term, right? We look for a family member of the first term, 7a, negative 2a. Are we okay? So we have negative 2a. The next number is positive 3b. So positive 3b has a family member of negative 4b. Negative 4b. Now 7a minus 2a. 7 apples minus 2 apples. You're having 5 apples. Now I have 3 mango trees, and then I owe 4. Let's make a banana, okay? So I have 3 bananas, and I owe 4 bananas. When I pay with the 3 bananas, I'll still be owing 1 banana. Now take note, in math, it is not wrong though, but once I have 1 mango, I'll just write 1 mango. Are you okay? But if I have 2 mangoes, I have to be specific. So 2 mangoes. Are you okay? But remember, if it is 1 mango, just write M. Everybody will understand that it is what 1 mango. So the same thing here. 1 banana. If I do this, it is still 1 what? Banana. Are you okay? Alright, that is the answer because you can't simplify further. Let's go to the second one, that is B. We have 5t plus 2q minus 2t plus 4q. Are we okay? As usual, you write the first one, 5t, which is a family member to 5t, negative 2t, right? Negative 2t. The next one is plus 2q, right? Plus 2q, who is a family member to plus 2q, plus 4q. Are we okay? Plus 4q. Are we done grouping like terms? Yeah, we are done. So 5t minus 2t. We have 5 teleportation machines minus 2 teleportation machines. We are going to have 3 teleportation machines. Are we okay? We have 2q plus what? 4q. We are going to get 6q. Are we okay? That is all because you can't simplify further. If you had the first one, congratulations. If you had the second one, congratulations. Now for the last one, we have 2 plus 2q minus 5 plus 4q. We have a raw number, that is a constant, right? 2. Who is a family member to the constant? 5 is also a raw number. Negative what? 5. Negative 5. The next one is plus 2q. Who is a family member to plus 2q? Plus 4q. Are you okay? Plus 4q. Good. Now what is 2 minus 5? 2 is positive. I have 2 cedis and then I owe 5 cedis. If I pay with the 2 cedis, I'll now owe 3 cedis. Are we okay? Plus, what is 2q plus 4q? 2 queens plus 4 queens gives us 6 queens. And that is our answer. If you've worked so far and then you had the answer, congratulations, you've done very well. Now, there are a little bit tougher questions I'm going to solve with you, and then I'll give you a similar example of those tougher questions. Are we okay? Make sure you copy the solutions so that you can revise another time. Are we okay? Yes, so this looks a bit scary, but it's very simple. Are we okay? So as usual, you take the solution and I'm going to give you example 4. Okay, I'm going to solve on your own. So solution, the first one, x squared plus x plus 2x squared. Are we okay? Remember when we were doing something about the mango, I told you if you have 1 mango, it's the same as what? 1 mango, like this. But if you want to be specific for the other ones, then 2 mangoes, 3 mangoes, and so on and so forth. Are we okay? So we have x squared signifying 1x squared. Are we okay? X squared, just 1. Are we okay? So x squared will be a family member of 2x squared. That is positive 2x squared plus 2x squared. Are we okay? Then plus x also counts. We have no family member, so we don't look for any other thing. Are we okay? Now x squared plus 2x squared, that is 1x squared plus 2x squared gives us 3x squared. So 3x squared plus our x. Very simple, right? Let's take B. 4x squared y plus 5xy squared plus 3x squared y minus 2x y squared. Here you have to take note of your like terms. You have to take note of your like terms. We have 4x squared y. 4x squared y. Who is a family member of x squared y? X squared y, no. X squared y, yes. So 4x squared y is a family member to plus 3x squared y. Plus 3x squared y. We are done. The next one is plus 5xy squared. 5xy squared is a family member to negative 2xy squared. So negative 2xy squared. Are we okay? Now we can add or subtract. 4x squared y plus 3x squared y gives us 7x squared y plus 5xy squared minus 2xy squared gives us 3xy squared. Now this is x squared y and this is xy squared. We can't do anything about them. That becomes our solution. Now the last one, the very last one, that is C. 7a exponent 4 plus 5a minus 2a exponent 4 minus 4a minus a exponent 4. 7a exponent 4 has a family member of negative 2a exponent 4. So 7a exponent 4 minus 2a exponent 4. Is there any other a exponent 4? Yes, minus a exponent 4. Remember I said when there is no number in front of a variable, there is 1 there. So negative 1a exponent what? 4. Negative a exponent 4. The next one is positive 5a. So plus 5a. Plus 5a. It's a family member of negative 4a, right? Negative 4a. We are done. Now, let's see a exponent 4 to be biscuits, right? So 7 biscuits minus 2 biscuits, right? A exponent 4 is seen as a biscuit, right? So 7 biscuits minus 2 biscuits gives us 5 biscuits. That is 5a exponent 4. Now 5 biscuits minus 1 biscuit gives us 4 biscuits. So the answer for everything here is 4a exponent 4. Are we okay? Plus, what is 5a minus 4a? We are going to get 1a, but we don't write 1a, but rather a. So this becomes our answer. Make sure you copy the solutions. You are going to solve the next set on your own. Alright, so this is what you are supposed to solve on your own. Make sure you pause the video and then you solve. If you copy, God is watching you. So pause the video and solve. I'm going to. Alright, so let's head to the solutions. Please pause the video before you watch the solutions. Alright, so A, we have 3c squared plus 7cd minus 4c squared plus 5d. Are you okay? As usual, we take the first term, 3c squared. So we look for another with c squared. That is negative 4c squared. The next one is plus 7cd. Do we have any other cd? No. But we have plus 5d. 5d, yeah. Are we done? 1, 2, 3, 4, 1, 2, 3. Yes. We are done grouping like terms. Now 3c squared minus 4c squared. I have only 3c. Let's see c squared to be markers. Okay, so I have 3 markers and then I owe 4 markers. I'll pay with the 3 markers so that I'll owe 1 marker. But remember, I've told you don't write 1 in a variable. Just that. Are we okay? Alright, we experienced some challenges, so I decided to continue here, right? So solution. The first one, that is 3c squared plus 7cd minus 4c squared plus 5d. Okay. 3c squared is the first term. Look for anybody. C squared, negative 4c squared. Right? We are grouping like terms. Do you have any other c squared? No. Let's go to the next one. Plus 7cd. Any other cd? No. There is 5d. That's all. Now we can solve this. 3c squared minus 4c squared. That is, let's say c squared is number of books. So 3 books minus 4 books. I have 3 books and I owe 4 books. I'm going to pay with the 3 books, so that I will owe 1 book. Remember, I said we don't write 1 attached to a variable, so we just have to write c squared, right? We can't add c, d, and d. They are unlike terms. If they were like, we would have added them, right? So we can still maintain plus 7cd and plus 5d. Are you okay? If you have this, kudos, right? Let's go to the next one. That is b. We have x squared minus 5x squared y minus 6x squared plus 2x squared minus x squared y. Are you okay? Now, x squared. Do we have a family member of x squared? Yes, negative 6x squared. Do we have any other family member of x squared? Yes, positive 2x squared, right? Positive 2x squared. Let's go to the next one because we've exhausted all the x squares. So you have negative 5x squared y. Look for another x squared y. Do you have any other x squared y? Yes, there is this x squared y, negative x squared y. We are done grouping like terms. Let's head to the calculations, right? Now x squared minus 6x squared. Remember, you should have written 1 here, but it is inappropriate, right? As a math student. So we have x squared, that is, I have 1 mango and then I owe 6 mangoes. I'm going to pay with the 1 mango and I'm going to owe 5 mangoes now. Remember, plus 2x squared. We are not done with the x squared. You can repeat the the remaining ones and then continue with your solution. Now I owe 5 mangoes and I went to pay 2 mangoes. I'll now owe 3 mangoes. Alright, I've told you already that you should see the negatives about debts. Are you okay? And the positives as our advantage or as money we have. Are you okay? Now let's go to the next one. I owe 5x squared y and I owe another 1x squared y. Remember, I said we don't write 1. If you don't see anything in front of the variable, it means there is 1 there. So I owe 5x squared y and then I owe another 1x squared y. So in all, I'll be owing 6x squared y. Very easy. You can simplify further, so if you add these two, kudos, right? Let's go to the last one. That is 14hk exponent 3 minus 2kh exponent 3 minus 2hk exponent 3 plus 3kh exponent 3, right? As usual, we pick the first term, that is 14hk exponent 3. Do you have a family member of hk exponent 3? Hk exponent, yes, negative 2hk exponent 3. Do you have any other hk exponent 3? No. So let's go to the next number, that is negative 2kh exponent 3. Do we have any kh exponent 3? Kh exponent 3, kh exponent 3, right? That is positive 3kh exponent 3. Once we are done with our grouping of like terms, we head to the calculation, right? 14hk exponent 3 minus 2hk exponent 3. 14 minus 2, we are going to get 12hk exponent 3. Exponent 3. Now I owe 2kh exponent 3 and I went to pay 3kh exponent 3. I'm going to be given a change of 1kh exponent 3. But remind you, I told you we don't write 1kh exponent 3, but rather kh exponent 3. Since that will be our change and not our debt, it should be positive. Kh exponent 3. Now hk exponent 3 and kh exponent 3 are not like terms. If they were, we would have added them to get our final answer. Congratulations if you have all the answers. We're going to continue to the next topic in the next lesson. Make sure you subscribe to the YouTube channel so that you get notified whenever I drop any new videos. Bye bye.